Hi guys, good afternoon. Sorry about the delay there. I've been having some trouble with Zoom today. In this morning session, it actually cut out after 30 minutes, so we had to restart the session. Let's hope that doesn't happen this time, but if it does, I'll restart the session straight away, and if you guys can just rejoin, then it should all go smoothly from there, but hopefully it doesn't drop out. Okay, so we got almost 20 people so far. That's good. Okay, we'll just leave it for, say, another 2 minutes just so people can join into the session because I just opened it. And then we'll get started.
Hey Xavier, I have a question.
Yes.
Yeah, so what happened is like there are internet servers down in Liverpool, which area I'm in. I have
Okay.
limited internet and like the dongle. They gave me the dongle for the 5G, like the backup, and it's like 50 gigs, and I don't
Yep.
think so it's enough. And I gotta get all my work done in like today's day for the first prac because it has been out from Sunday 19th.
Right. Okay. Yeah. That's fine. If the other thing you can do is you can attend a practical session next week on Tuesday. So, like I said
No, no,
before, these.
I'm worried about the practical that is due today.
Oh.
Yeah.
Um, I don't look, to be honest with you, I don't think access to the internet should stop you doing the practical today that's due today. Uh, you're not going to need too much data, right? You're not going to be
I mean,
needing to
like,
download or upload too much online to complete the practical work.
yeah, but the thing is that it won't be available for this whole week, and I have gotta save it for the whole week.
Yeah, okay. Are you using it now on this Zoom session?
Yes. Yeah, I'm using it right now. Right now, it's sitting at 8.4 gigs, and I gotta use there's about 50 gigs, and I gotta
Yeah.
use it till I think I would say 28th.
Okay. Then what I'd recommend is jump off this Zoom session now because you're just wasting data. It's going to take a lot of your data. Jump off the Zoom session, finish your prac and submit it tonight using, like you'll save, I don't know what, this is going to take a gig or something for an hour of Zoom. So jump off now, finish your practical and submit it today, and then jump onto the practical session next Tuesday, and hopefully you've got it sorted by then.
No, 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 the thing is that the outage is going to be till the whole week. So not only just this prac, I gotta do like my analytical prac, I gotta do my other subjects, and it will take a lot more because they have like graphs and everything else to do because I have to dig data from the simulator and stuff.
Okay, so you're worried you're not going to have enough data to complete. You're not going to have enough, transfer data available to
Yep,
complete your work for all your units.
yep.
Okay.
For example, even like other units, I gotta like upload my whole laboratory manual on Friday, and it's gonna take a lot because the uploading thing takes a lot of gigs, and that's what I'm worried about. So if I can do something, if you guys can like give me like like extended due date to do all of this stuff, so I can take everything slow and carefully manage my data.
Yeah, I'll have to talk to Feng about it because it's a bit of a strange circumstance. I I don't see how your data is going to restrict you completing the work that's due today, to be honest with you, because all you need to do is upload photos or scan copies of your lab book, which won't take much at all. Um, so, have you already watched the lab demonstration video for the prac that's due today, the
Yes.
alumni macaque? Okay, that's good because
Yeah, I started doing it, and I don't know, but I'm just like a little bit worried about it because if it lasts for like 1 week or if they extend it at that point, I don't know what I'm supposed to do.
Yeah. Look, I would say again, my position on it is to is like don't worry about doing this practical session now, because as we're speaking, we're wasting your data. Complete. I think you should be able to complete the stuff that's due tonight without chewing through too much data. I don't think you
Okay,
need
but what
what
about
you don't.
the you know, the like the marks for the like entering the attendance and everything?
Well, that's what I'm saying. So attend the prac next Tuesday. Hopefully internet's sorted by then. But if it's not, like, then we'll cross that bridge when we come to it. If your internet's not sorted by next Tuesday, where the prac session's on, we'll have to and you can't attend it, then we'll cross that bridge. But at least these practical sessions are recorded, so you can watch it later when you do have internet.
For the next is
Because I
the
can't.
28th, right? If we have the if I go to Campbelltown, isn't the experiment due the same date, the 28th?
No, the report for this experiment is due on the 12th of October. So even
Okay.
if you attend the prac on the 28th, you still have 2 weeks to complete
Okay,
the
thank you.
report.
Just complete this one, and after this prac, which has to be done due this date, and the next one will be at 12th of October. Is that correct?
Correct. Yeah, the aluminium
Yeah. Okay.
ACAC
Thank
prac
you.
is due tonight, and the vanadium prac, which we're going through today, is due on the 12th of October.
Okay. Thank you, Xavier. Thank you very much. I will leave this one.
Okay, thank you.
Thank you very much.
Cheers. Bye. Okay, so sorry for the delay going through that, guys. You have been patient with me. Let me just.
Xavier, will we have a time at the end to discuss something? I have quite a big issue that's sort of my own doing over the last semester.
Yeah, that's fine. Yeah, we can. Yeah, I can certainly hang around and have a chat to you. If it's not directly related to what we're doing here and everything, if it's just more of a something you want to discuss one on one, that's fine. We can hang around and discuss that. If it's something you think would benefit everyone to hear, then you can do it when everyone else is still on.
No. It's
Okay.
mostly to do with attendance.
Okay. Yeah, that's fine.
I
You and I can discuss that at the end. That's fine. That's all good. I'll make sure I hang around. Okay. All right. Okay. We'll get started. So I assume by the interactions I've had so far that everyone can hear me okay. And I've shared my screen, so hopefully you can all see that. And we'll get started on this session. As usual, it's going to be around about an hour. Like I said at the start, for some reason it dropped out after 30 minutes this morning, so I really hope that doesn't happen again. If it does, I'll just restart the Zoom, and if you guys can jump back in, that'd be great. So today we're looking at Prac 3.4, which is the synthesis of preparation of the vanadium acetylacetonate complex. I did upload an introduction video, but it was pretty late last night, so I don't know how many people have watched it, but that's fine. We'll go through everything that was in that video. We'll go through now today, and also we'll go a little bit deeper into things as well to help you with the report writing. So as I mentioned a little bit earlier, there's a report due for this prac on the 12th of October. So that's a formal report, and it's nothing to be intimidated by, because it's not that dissimilar to what you guys have been doing for your lab book so far in regards to writing introduction, results, discussion, etc. The main difference is that this report has to be referenced, right? So you'll find references online, peer-reviewed articles or textbook chapters or the like, and you'll reference them in your report. But we'll go into the report a little bit later on in this session, and it'll all be pretty clear to you. So we'll jump right into it. Sorry, I'm just replying to someone in the chat. Okay, we'll jump right into it. So first thing we've got to get out of the way, in your lab manual, in the introduction for this prac, there's a bit of an error in that in the introduction it says that the experiment is kind of in two parts. The first part is making the 5-coordinate acetylacetate complex with vanadium-4. And then the second part is making the 6-coordinate ammonia adduct. We've simplified it. We're only doing the first part, so we're not doing the ammonia adduct. You'll notice in the lab demonstration video, if you've had the chance to watch it, we don't make the ammonia adduct. And also in the procedure in the lab manual, it also doesn't go through to make the ammonia adduct. So the only error is in the introduction to this experiment in the lab manual. So basically we can ignore all of that part. So we're just doing the first part, which is the 5-coordinate vanadium 4 complex. So just to get that out of the way in case that confuses anyone. As usual, feel free to write any questions in the chat as I'm going. I'm happy to answer them along the way, or just turn your microphone on and let me know. And also at the end of the session, we'll have time to go through and discuss anything that's not clear so far. Okay, so we'll have a look what we're doing, and there's not a whole lot to go through in this prac actually, because there's not too much new theory at all. We've already been through, coordination complexes, the various characterization techniques, IR, UV, NMR. So there's not a whole lot of new content to go through, and there's actually quite a bit of similarity between this experiment and the aluminium ACAC experiment. Well, it's the same ligand for a start, and as you can see here, the structure on the left and the model on the right. So we've got 2 of the ACAC ligands coordinated to the vanadium center. That's actually a vanadal center. It's vanadium double bonded to oxygen. So similar to the aluminium ACAC complex, this time it's a 2-to-1 ligand ratio instead of 3-to-1 that we had in the aluminium. Again, we've provided you with a little table of information that might come in handy, and similarly to the aluminium prac, probably the thing to, well, the molar mass will be very useful for you when you're calculating your theoretical yield, but also the solubility in water. So keep an eye on that like you did in the last prac, and that'll help you explain some of the steps in the methodology for the prac, especially filtration steps, and also explain the choice of solvents. So that'll be good for your discussion in your report. So the ACAC ligand, all of this we went through previously in the aluminium prac, but we'll just touch on it very quickly again today. So if we remember, the ACAC ligand exists in equilibrium between the diketo form and the enol form. Again, we gave you some relevant data on the ACAC ligand. You can see the empirical formula at the top, C5H8O2, so it's for the fully protonated form, 8 hydrogens. The density and molar mass you'll use like you did for the aluminium prac. You'll use them to work out the number of moles used in the experiment because it's in a liquid phase. And again, looking at the solubility in water, that'll help inform your observations and explanations for the methodology. Yeah, so existing in a equilibrium between the diketo, the enol form, and as we talked about in the last prac, also this deprotonated form. And because of that, we can say acetylacetone, sorry, a mouthful, ACAC, is a weak acid because it's fairly happy to give away its proton. So you can see there the equilibrium expresses empirical formula, and we have the dissociated proton form on the right. So like we did in the aluminium prac, we have to, or we're more likely to form a coordinated complex if the ligand and metal are in alkaline conditions, basic conditions. So again, for this prac, we'll be adding a base to help push the equilibrium to the right, to the deprotonated form, which will then coordinate with the 2 oxygen binding sites. So all of that's pretty familiar from the last prac. We'll have a look at the methodology for this prac. So this is just lifted straight from lab manual. Just screenshotted it, and you can see that the experiment that we do can be broadly kind of broken down into 2 steps. Now, the first step is the reduction of vanadium-5 to vanadium-4. And the second step is then the coordination of the ACAC ligands to the vanadium or vanadyl center. So we'll have a look at step 1 first, right? So our starting material is vanadium oxide. We've got the structure there. And then we're dissolving it up in water. We're adding concentrated sulfuric acid and also ethanol. And for this reduction reaction, we have to have a look at the vanadium metal itself and the oxidation state of the vanadium metal. Now, you're probably all fairly familiar with oxidation numbers, but we'll just go through it really quickly now, because figuring out this balanced equation is important for your report. And the first step to figuring out the balanced equation is recognizing that the vanadium is being reduced, and so there must be a reducing agent. One of these starting materials, starting reagents, must be a reducing agent, and you have to figure out which one it is. So anyway, we'll start with the vanadium oxide starting material. We see V2O5. Now, oxygen has an oxidation number of -2. We've got 5 of them, so that's -10 in total. And because the V2O5 vanadium oxide compound is overall neutral, doesn't have a charge, so we can look at this similarly to how we look at coordination complexes, when we look at the ligand, the charge of the ligand, the charge of the overall complex, and work out the oxidation state of the metal center. So if we apply that theory to V2O5, we can say, well, the overall compound is neutral. The oxygens are contributing a 5 times -2, so -10 charge. That means each of the vanadiums must be contributing a +5 charge. So that's where we get vanadium-5. That's how we know it's vanadium-5. So in your balanced equation, the product that you get, the vanadium product that you get from this first reaction, you're going to have a look at the oxidation numbers and double check that your vanadiums will have a oxidation number of +4. Okay, so that's something to keep in mind when you're figuring out what your product is, your vanadium product from step 1 reduction reaction. So as we said, we need to reduce the vanadium from vanadium-5 to vanadium-4. Therefore, we need a reducing agent. And we also call this a reductant. So you might see that written as well. So reducing agent is a reductant. And due to the nature of redox reactions, the reductant or reducing agent will be oxidized. So we've got to look at the other starting materials. So we've got water, sulfuric acid, and ethanol. We've got to look at those other starting materials and say which one's most likely to be the reductant. And we base that guess off which one is most likely to be oxidized in this reaction. So this background is kind of helping you figure out the balanced equation for step 1. And as I mentioned, the first thing you've got to do is work out which of your starting materials is going to be the reductant. Well, there we go. Which reagent's the reductant? Which reagent can be oxidized? So in general, right, I'm not going to be specific at this point, but in general, we're then going to end up with a vanadium-4 compound, right? So we know the vanadium-5 oxide, the vanadium-5 is reduced to vanadium-4, and we'll end up with some kind of vanadium-4 compound. We're not exactly sure what it's going to look like yet. That's for you guys to work out. We don't, like, I'm not going to write the empirical formula up here for you. But you can work it out yourselves. And we're also going to end up with a byproduct, which will be oxidized. So it's our our reductant that has been oxidized. That'll be a byproduct. And then we also might have some kind of spectator, waters or maybe gas released or that kind of thing. So that's step one. Step two is the coordination reaction, which is a little bit more straightforward because it's very similar to the reaction in the aluminium ACAC experiment. So we'll start with our vanadium 4 compound, which we made in step one, excuse me. And then we'll add the ligand, ACAC in its protonated form there. And as we discussed earlier, we'll also add the base. In this case, it's sodium carbonate, and that'll be in water. And what we'll end up with is our vanadium final product, VO-ACAC2. Plus, we're going to end up with some byproducts, and that again, that's for you to work out. So you won't be able to work out step two without working out step one. So start with step one and start by identifying the reductant, the reducing agent. So if you once you've gone through that process, that will inform a big part of your write-up for the report. There's a fair bit to write about there. And as far as the report goes, for kind of direction on how to write it, how to get started, there's a couple of places that you can go and look, right? So the first place to look is in the lab manual. So I'll bring it up here. So page 4 of the lab manual. You've got a pretty comprehensive explanation here of what's expected. So starting on page 4 gives you an introduction, and then the important thing to note are these headings. So it's a requirement of the report that you follow the layout that's been stipulated here. Use all these headings. Importantly, when you go to reference, right? So it says somewhere up here, report should follow the format of research papers. For example, inorganic chemistry and ACS. So it's important to follow the referencing style that we've laid out here, right? So I've given you examples here of journal articles and books. The referencing style for an ACS publication, you can look that up. It's most similar, I think, to the Vancouver style, where in-text citations are numbers, either superscript or in brackets, and then the reference list is laid out like these examples. So important to follow the examples of the references. Other than that, yeah, follow this kind of layout and these headings. The other place that you can go to have a look for some information is the marking scheme. So you find that on views. Now, I'm not sure if I have views open. Yes, I do. Right. So in views, on the home page, there's your learning guide. Right. So if you open it up and go to page 11, you've got the marking scheme here for the report. So again, it's given you these subheadings: introduction, experimental results, discussion, conclusion, etc. There's also a mark awarded actually for following the specified layout. So that's using all the subheadings and also with an appropriate title. So you can see here the various marks awarded and also the what you need to do to get the marks. And again, we have here references, not a bibliography. So you're not just listing sources at the end of the document, you're actually citing them in text. So if there's any knowledge, if you're making any claims to knowledge that's not your own, you have to give it a citation. So for example, if you're saying maybe the bond length of the vanadium oxygen bond of the vanadal is, I don't know, for example, 1.55 angstroms, you have to have got that knowledge from somewhere, so you'll need to reference that claim. So you'd have an in-text citation for that claim. So yes, it's a reference list, not a bibliography. Must be in the form more or less same as ACS. So you can also look up the ACS style, but it's most similar to Vancouver as far as numbered in-text citations go. And aside from that, you can also follow the example layout for references in your lab manual. Also, a good place to start with the report is if we go back down to where the actual Prac, the experiment is, the vanadium acetyl acetonate. So we've got a little section also down here about the report that you have to write. And a good place to start is with these references that have been provided. So you can find them online for the most part. In fact, they should all be able to be accessed online. Definitely start with them. Don't limit your report to only using those references. Definitely branch out. We'll be looking for, we'd like to see references other than what's in this list. But definitely start with these, and I would say aim to include all of them in your report. All of them have something to offer. Some of them you might only say this one. You might only really use the infrared spectra from it, but it's definitely got something to offer. So have a look at them as a starting point and then branch out from there. If you haven't done much referencing before or looking for references, a good place to go is the library webpage. So you can go to your MyWestern homepage. I'll sign into my student account, so it's more what you guys can see. I'm having trouble signing me in, of course. Maybe I have to do it on my staff account. I'll have a look. There we go. Okay, so start at the MyWestern homepage, then go to the library link, and you can basically type your whatever journal article you're looking at here. You can search for keywords. I find a good way to do it is to say start just with Google because it's nice and easy, and you can start just typing keywords and try and find some articles that way. You can also go to Google Scholar which will return peer-reviewed articles. For instance, here we have one from ACS, Electrochemical Studies of Vanadium-3 and Vanadium-4 acetylacetonate complexes in DMSO. So that could be pretty handy for you. So if you find an article like this that you want to use, make sure you reference it, cite it and reference it. The other thing is you might not be able to access all the articles through Google because a lot of them are behind a paywall, okay? So if that's the case, you can also just take the title of the article and search it in the library. Okay, and then you get the results through the library website. And so, like I said, a lot of the articles might be behind a paywall, but the university pays big money to give us access to various journals and publication houses. So if you go through the library website, most likely you'll be able to access all the articles. So even if they're behind a paywall just through Google, search them in the library website or through the library website. You'll get all these results. It'll say available online. Click that. It'll come up with various databases where the article is hosted. Often it doesn't matter which one you choose. I usually just choose the first one. If it doesn't work, choose the second one. It'll ask you to sign in, and then you'll have the article available to you on the publisher's website, and you can download the PDF. You can also, if you're using referencing software like EndNote, you can also export the citation data there. And you'll often have supporting information like data that they've collected, spectra, and the like. So that's just a little introduction to searching for resources in case you haven't had to do it too much. Go through the library website. That'll give you the best access because universities paid all the fees for you. But if you want to, you can start by using Google or Google Scholar just to find the article and then copy and paste the title into the library website to actually access it. So hopefully that helps you with the report. Now, I've got this notification from Zoom about the fact that the meeting's going to end. So anyway, if it does, I'm sorry for that. Apparently it's going to end in 8 minutes or so. If it does, I'll restart it, and please just join in again. I've got a question from T in the chat. For formal report, do we type in Word file or handwriting? Definitely type it up because, yeah, it is a formal like assignment submission. So type it up. And what style of references? Yeah, so as Matt said there, ACS style, which there's not actually an ACS style guideline on the Western Sydney University Library website, but there's many ACS style guidelines online. Especially from other universities. So if I have a look here, if you simply type ACS style, right? A lot of universities. So I looked at one earlier from Macquarie University that was pretty good. So Macquarie University has got this guide to referencing in ACS style. So you can use that. Importantly, the most important thing to do is follow the guide of what we've laid out in the Prac manual. So this guide here. So for a journal article, you'd first list the authors, the journal in italics, right? Italicized journal, the year in bold, volume, italicized, and then page. Keep in mind the commas between them as well. That's important. So what this is, it's kind of an exercise in, because when you actually, or if and when you write a journal article for publication, each publisher or even each journal might have its own slightly different style, and you have to adhere to their parameters accurately in order to get published. So in this case, we've provided you with a style example here, and you have to adhere to this style. For general kind of explanation of the ACS style, have a look at a website like this. Specifically, when you go to format your references, make sure they adhere to these styles here, because that's what we'll be marking you on. So hopefully that answers your question. Okay, no worries. Yeah, thanks, Matthew, for also contributing to that. Does the issue number need to be included with the volume number? It should be. I'm not sure if we've specified it here. Volume, yeah, so it should be in brackets, I believe. Yeah. I'll find it straight over. But yeah, I'm pretty sure it should be in brackets after the volume number. Let's see if this one has it. So journal articles. So most of what you'll be referencing will be journal articles. Okay, so not the issue number. There you go. So yeah, no need to list the issue number, just the volume number for ACS. And yeah, that's reflected in this example here. So just the volume italicized. Another question from T. Do we have to draw the equation in results part of only calculation? You'll need to draw the equation. You mean the equation like you're working out for your calculation? Is that what you mean? Or you mean the actual chemical equation? As far as if it's the chemical equation, okay, the chemical equation, you don't need to put that in your results. Definitely put it in your discussion. Really, the only result as such per se from this experiment is going to be the yield. So just make sure in the results section you have your calculations for yield and theoretical yield all laid out nicely so that we can see what's going on. But that's kind of the only result. The rest can be in discussion. Your chemical equations and your observations from the lab demonstration video and all that kind of thing, that can be in the discussion section. Okay. Any other questions?
Yeah, I had a what was, or should I wait? Because I had something to discuss with you.
Yeah, that's fine. I'll this meeting's going to end in 1 minute. So I'm gonna restart the meeting actually in about a minute. So please everyone rejoin because I'll go through as a bit of an incentive to rejoin. I'll go through the chemical equation and give you a better idea of what the reductant is. Just quickly, so yeah, Brian, sorry, I'll talk to you at the end if that's okay.
Okay, yeah, no worries.
Cool. And just quickly, Matthew, is a pre-work and results used separately to the report? Okay, for this one, all you need to submit is the report. So you don't need to submit a lab book. There's no results sheet. It's just the report because what you would do in your lab book will be basically what you do in the report. So that's it. Just one assessment item for this prac. Okay, all good. Okay, so let me restart this meeting. I don't know why it's doing this today, but anyway, I'll do that. Please join back in, and we'll just spend the last 10 minutes or so going over the balanced equation, give you guys a better start on that. So please rejoin, and I'll catch you guys very soon.